Good morning, friends and YouTube channel viewers. Myself, Professor M.H. Annaya. In this video, we are given with the orthographic views of a simple block which has got length equal to 50, width is equal to 40, and height is equal to 40, with some projections at the diagonally opposite corners of height 20 mm and also a square slot exactly in the center of this. Friends, first of all, as per the fundamental concept, let us write down the overall dimensions, namely the length is equal to 50, width is equal to 40, and height is equal to 40 as shown. Friends, if you observe the top view, above a height of 20 mm from the bottom face, that's the bottom face, there is a projection of height 20 and width 15 at the corner here. At this corner, you have this. Friends, now we can just write down these projections at the extreme end. That is, this has got a dimension of how much? That is 15 width. This is 15 and this is 10 mm. 15 by 10 mm. There is a projection there. So friends, how to complete that? So let me start. Write the top view of that, and top view appears as a trapezium or a parallelogram to say correctly. This is what I have shown here. So this part I am completing now. So this top part I have completed and it has got a depth of 20 mm. So from all these corners, I am going to draw vertical lines of height is equal to how much? 20 mm height. So friends, this is one of this face. This face is this one. And similarly friends, let us project from these other corners and write down or complete the projection on one of these ends. Friends, if you observe from the front, this has got a projection of 20 mm. This is 15 mm. That is, in the front view it is going to be 15. This is going to be 15. Yeah. From the front you are looking, the width is going to be 15, right? And this is going to be 10 in the top. This is 10 by 15. And the height of this is given to be 20, that you can see in the front view. This is 20. Similarly, friends, we have on the diagonally opposite corner, there is a projection that is 10 by 10 projection in the diagonally opposite corner. So here there is a projection at this end. You can see there is no connection between that. And friends, on the same lines, let us construct a box here of dimension 10 by 10. This is the top you have drawn with this face. Draw vertical lines from all these. And this has got a projection, a square block like thing or a square prism of dimension 10 by 10. This is 10 mm and this also 10 mm, 10 by 10. And friends, now this is the top surface of the block. Let me complete that top surface. There is no connection here, so I am not supposed to join that. So we will have the completion of this part. So this is the last line, extreme end line. This is the extreme end line we have got, friends, till here. Then this has got a height of 20. This is also a base edge these two are parallel to each other. And friends, I'm just completing the top surface of the block by completing all these lines. So friends, if you are looking from this end, this is in the front view, you see like this. In the front view, this slot will come later on. And friends, now it is better we remove these extra lines so that it becomes easy to visualize and we can have a better picture of this block. So I have removed all these unwanted lines. Friends, here exactly in the center of this top surface we have a slot. That slot is of size 10 by 10, that you can know from here there is a slot. Okay, so we are going to mark exactly in the center of this. Say if we extend this line by thin line, we had a line like that, friends, exactly in the center of this block, which can be marked by joining this center of this line to the center of this. You are going to have the block divided into two equal parts. So exactly in the center of the top face, friends, we have got a slot 10 by 10. So friends, from the center, I will take 5 on all the sides. So 5 from this side, 5 from here, 5 and 5. So friends, we are going to join all these like this. So I have taken the distances. I will just draw lines parallel through that, parallel, and friends, this is this square slot which has got a dimension 10 by 10. Say this is a square slot, dimensions of which are, this is 10 and that is 10. And friends, these two lines here indicate the last edge, these edges. They are visible. Hence friends, I am going to show this top face. So till here I will write down. Friends, this will give you the top surface of this block. And friends, slot I have shown. Friends, you can see here the thickness of this is 20 and this is only 10 by 10. So friends, we can just draw a vertical line through this slot, a vertical line through that till it touches here. So this will represent the corner or the vertical edge of this slot. Now friends, if you observe this figure, let us verify whether the drawing, the isometric drawing we have got, is drawn correctly to the orthographic views given. So you have to start from the front view. Say, friends, in the front view, you have got two projection, one at this corner that I will show by color here. This is one at the left corner and the other at. So for this, if you look from the front, you are having 15 width by 20 depth. This depth is 20. That can be seen. Similarly, friends, in the front view, you have got this 10 by 10, 10 by 10 projection at this corner. So that I have shown by these two lines. So this is 10 by 10. Since it is at the front face, no line comes here. So this is 10 by 10. And it has also got the height equal to same 20. This is 20 and this is also 20. And if you look from the top, friends, you got these two projections on the diagonally opposite corners, and there is a slot, a square slot, 10 by 10 size, made exactly in the center of this plate or the platform to say. So friends, this will give you the isometric drawing. I will say ISO drawing which is also called as isometric view. And these isometric drawing or isometric view are always drawn by taking the dimensions from the orthographic views to a scale of 1 is to 1. That means whatever the dimensions you have got here, same thing you are going to mark on two lines which are inclined at an angle of 30 degrees to the horizontal. This is 30 degree, this is also 30 degrees to the horizontal. And friends, the same question, if you are asked to draw the isometric projection, the figure is going to be similar to this, but it will have all these dimensions reduced by around 18.5. That is, if it is 50 actual here, this will be 50 into 0.815 approximately. This will have 42 millimeter dimension, this will have about 33 dimension, and so on. Friends, I hope the presentation was interesting, and if you like this video, please share this video and my YouTube channel link, Mechanical Engineering by Dr. M.H. Channaya, with all your friends without fail. Have a good day. Thank you for watching my YouTube video.